Right. Good afternoon, everybody. Yeah, headsets on, everyone, headsets on. Good afternoon, everybody. For anybody who was here yesterday and here today, I applaud you for making it through 2 days of Big Data London, and also applaud you all for making it to the after lunch at Big Data London. You're all heroes. So hopefully you're all in the right place, you're in the right room. We're going to be taking a little bit of a look at some of the history of large language models. It feels like today, right, you can't really do pretty much anything without somebody trying to talk to you about large language models. I generally can't talk to any customer without it being an aspect of their platform or something they're thinking about doing. And so what we thought we'd do is we'd run through a bit of a history to see how we've got to the point where we are, and potentially, are we at the end of that journey, or where are we potentially looking to go beyond it? So a little bit about me. Hello, I'm Terry McCann. I'm the CEO of a company called Advancing Analytics. You might have come over and played on our arcade machine and won some socks or some Lego. We're all the way over there. And so I'm a Microsoft MVP for artificial intelligence, which generally means I just spend too much time at events talking to people rather than doing any real work, but that's okay, that's what we love doing. I also run a podcast called Totally Skewed, and my lovely Totally Skewed co-hosts are here as well, so do check it out. A little bit about us as a company, there's some stuff there, but let's get into the meat of it. So before we get into the session, set a little bit of context, right? When we talk about large language models and generative AI, it's worth setting the scene a little bit about where we've come from and how we've got here. Because it feels a lot, right, probably in the last 6 to 12 months, that there's just been this huge acceleration in large language models. They litter our news feeds, they litter our newspapers, they litter our conversations, right? Everybody is always talking about large language models, but it feels very, very kind of much like really accelerated at the moment. And largely that's through a process of essentially, we've got to the point with machine learning and deep learning that a lot is being commoditized. But with everything, there's a huge history, right? So going all the way back to the 1950s, where artificial intelligence was really invented, it's where we started before things became that bit simpler and we started getting reinvestment. You'll see over time there's this concept that's known as an AI winter, and it's this period where a lot of interest is put into machine learning and into artificial intelligence, but then sometimes it doesn't quite equal out with what you were expecting, and so funding begins to dry up, and we end up falling into an AI winter. And so we did in the 1950s, and we did in the 80s, but there are a number of people that really continued to invest in deep learning, people like Yoshua Benigo, Yann LeCun, Geoffrey Hinton, all who collectively a few years ago won a Turing Award for the work that they did. And it's a lot of that grounding that really has got us to the point where we are today. And so with that, and with the extension of what they were doing, that really pushed us towards what we had with deep learning. And for a long time, deep learning was really, at this kind of like unachievable level for a lot of people. There's a huge, huge amount of knowledge and understanding that had to go in to you actually being able to build something that generalized to the problem you were trying to solve that used deep learning, and it was incredibly complicated. But now you'll find a lot of data science teams are actually tending to do more engineering work, and there's a lot of data science work that's shifting a lot more towards being more machine learning engineering focused. And that's because a lot of this stuff, right, is becoming so much easier. With things like AutoML, with a lot of the great tools and vendors that are here, actually solving some of these problems isn't really that challenging anymore. But actually solving a lot of the production problems as well as a lot of interest for a lot of people. And so a lot of this stuff is shifting. And really it's the commoditization of deep learning that has really pushed us towards generative AI. And so it's generative AI, right, that we kind of want to be focusing around our talk today. So, as mentioned, I hope you are all in the right place, right? This is a talk you should be seeing here. Now, when it came to saying, when Andy emailed one of the organizers of Big Data London and said, the sessions are open for submission, what do you want to submit? I may have left it a little bit late. I might not have been as proactive as I possibly could have been, and so I might have cheated a little bit, right? And I cheated. I got ChatGPT to write my session title, and I got ChatGPT to write my session abstract. I absolutely cheated. And so actually the talk you're seeing today, right, was actually generated by a large language model. And so it was run through using ChatGPT. Now ChatGPT is ultimately towards the end of this history of large language models, right, in terms of what it's doing. But what I want to do is maybe roll that back a little bit and start thinking about, what really these language models are and how they're working and what they're doing. But before we do that, right, quick show of hands, who's been using things like ChatGPT, generative AI in some way in their kind of daily lives at the moment? Yeah, right, it's a huge, huge amount of hands. I do, and if you attended my talk earlier, you'd have heard me say that if you go over to our booth and you pick up any one of our leaflets, they sound quite compelling. I am incredibly dyslexic, so me writing copy is a terrible idea, but me writing terrible copy and then getting ChatGPT to help me, phenomenal idea, right? And so you'll find a lot of that stuff has been generated, has been tuned, so that you can understand what we do as a company in a much better way. And so yeah, you'll see, right, it has infiltrated our lives absolutely all over the place. And you'll probably be sat here, and most of the companies you work for might have a small generative AI task force, right? Who are trying to decide, well, what do we do? What are the potential really exciting use cases that we have that we could be looking at and actually looking to get started with this stuff? And hopefully, after this talk, the barrier might be reduced a little bit in terms of that. So let's go through it, right? Let's have a little look about what we've been doing. And so, as a company, and even before we were a company, we've been helping people build machine learning models for a whole host of different reasons. And I remember when we started with things like bag of word models, and feeling like we were creating these incredible things, right? What a bag of word models was, in kind of natural language processing, is you would take a corpus of text, and you would give that to a model, and what it would do is look at each one of the grams, so each token, each word essentially, and we would look at kind of the popularity of those words, and we might take the top kind of 1,000 of them, and we might use a bag of words model to ultimately build out some kind of classification problem. I remember we worked with a customer in trying to classify years and years ago, if somebody was buying something on a receipt, what did they buy? When it said BTL Bud, was that a beverage, was that food? Or when it said Budweiser, or when it said a bucket of Bud, all of these things, right? There were these words that we could use to ultimately train a very simple classifier to say, this is actually a beverage. Or no, this Budweiser sauce, it's not a beverage, it's actually a sauce that you use. And so that's actually like a condiment or food, right? And they were super simple, and they were not incredibly effective, but they worked, right? And so we built bag of word models for a long time. Then we started getting more complicated with things, right? We moved to things like word embedding. Word to vec became this like huge, huge phenomenal kind of process that we could look at. And what word to vec was doing was taking words, and rather than looking at things like popularity and the kind of repetition of numbers, it would start looking at the context between words. And it would do that by mapping them in what's known as like an embedding space. So you could start doing these really interesting things, and you might remember these kind of examples from years ago, where you could take a word king, and you could say king versus man, and it would come up with queen. Or you could say woman plus crown, and it would say queen. And you could do these things that were just like mind-blowing at the time, but now feel so naive and so simple when you compare them to what you can do with modern large language models, that it just feels quite astounding now. But word-to-vec models actually enabled us to do loads of really interesting things, and when combined with other deep learning approaches, we were able to do some really incredible and powerful stuff. Then started, really being the rise of recurrent neural networks and convolutional neural networks. And so when things like ResNet became very popular from a convolutional neural network perspective for doing a lot of image-based analysis, we started thinking, how do we start applying a lot of these deep learning concepts, not to things like images, where we're able to apply convolutions and actually be able to look at the density of pixels and how they're spread, but actually how do we start doing that with text? And one of the approaches that we started looking at was a thing called a recurrent neural network, which is a very kind of iterative process. And it got us somewhere. We could do some interesting things, but the problem that we had is that they were so procedural. So when we were looking to generate text, what we would do is we would train a recurrent neural network by looking at each word one by one. So we would go through a document, and we go through thousands of documents, big corpuses of text, right? And we'd go word by word, and we'd start to build out a deep learning model, which basically started to map the probability of what the next word might be. Now, in a standard recurrent neural network, that was quite challenging because it had no idea of the history of the words, had no idea of the context of where that word was in a sentence, and so you generally end up generating like something that worked, but generally it was just utter garbage. And so we needed some way to start thinking about history. And with history, first came the long short-term memory model. And so this was a different flavor, a different iteration of a recurrent neural network that had essentially a small amount of memory. And so it became far more context aware. And with it, you could do some really interesting and humorous things. So out of interest, who likes Harry Potter? There should be more hands. I'm judging you all for not liking Harry Potter. But years ago, going back to, kind of like the 2015, 16, 17 time, people were using LSTMs for really interesting things. And there were always these stories about how they were being used to create funny and interesting processes. So those who said, yes, I'm a Harry Potter fan, how many of you have read all the books? Most of you, right? Have you read this book? Harry Potter and the Portrait of What Looked Like a Large Pile of Ash? So this was a book, this is, 2017 or something like that, which was created by a team using a long short-term memory model. And so what they did is they took all of the 7 Harry Potter books and they tried to use it to train a new Harry Potter book. I think they only actually trained a chapter because it would have been a monumental amount of work to actually build like 300 pages. But it had some incredible stuff in it, right? And if you think, right, what we're doing here is we're generating word by word, because it's recurrent, and it's trying to come up with the probability of what that word might be next. And so you ended up with things like this. Things like great quotes like, "Voldemort, you're a very bad and mean wizard," Harry savagely said. Hermione nodded encouragingly, and the tall Death Eater was wearing a shirt that said, "Hermione has forgotten to dance." So Hermione dipped his face in mud, right? So it kind of sounds like something that you might have used, right? But it really was still, again, quite naive in terms of what you were doing with it. And so didn't quite achieve really, what we wanted. But with long short-term memory models, you could do some interesting things. So for a long time, I used to have a conference talk that I would do at places like Big Data London, which was generating a new talk. And what we would do is we would use we'd use Python to go away and scrape all of the talks that had been submitted to that conference, and then we would use that to generate a new talk. And the problem that you have with this type of process is it was really, really heavily biased towards the first word that you used. So depending on that first word, you would end up generating something. So to actually build out this chapter, what you would actually do and what the team did is it was heavily, heavily selective. So they would generate something, and then they would generate something else and something else and something else, and collectively pull these things together to create something that feels a little bit coherent. But really, it could never do what something like ChatGPT does now. And really, when we're looking at wider with language models of what they potentially could do in the future around things like book generation. And you might have seen on LinkedIn, if you mention, language models at any point, you'll start getting these adverts, right, for people who made prompt engineering books and how to write prompts better. And you can guarantee, overnight, there's books of 50 pages. They didn't write that stuff, right? They just generated it for every page. And so being able to do this, if you were to try and do this today, you would get a much, much better, more convincing story that potentially might look something a bit closer to what you would expect from another Harry Potter novel. But there were other really interesting use cases as well. So somebody created a short film. I've got it embedded in here, but I won't play it through sound and other challenges. But I recommend you go on YouTube and Google it and actually have a look at it. Again, because it's utterly garbage. But what somebody did is they took pretty much I think it was something like 80 or 90 screenplays for science fiction films, and used that to generate a screenplay. And there was lots of stuff like this. Google were doing a lot with LSTMs around things like generating new Shakespearean sonnets. And again, the world were blown away by this stuff. And it never really came to fruition in terms of a long short-term memory model because they were so incredibly limited and so incredibly biased. But somebody used this to generate an entire film, and it's a film that you can go and watch, and they actually hired a bunch of actors, probably quite familiar if you've seen Silicon Valley, and they hired them and they got them to act it out, and they acted out this screenplay. And there's a whole load of really random things in here where someone opens up a bread bin and there's a skull inside it, and all sorts of really stupid things, but they were used to create some really interesting use cases. But they were definitely just way too limited, right? They didn't have the breadth of what you would want from actually building something that could add value and transform your business. So as mentioned, they were using recurrent neural networks and a type of recurrent neural network called a long short-term memory model. And what these little loops represent are what called memory gates. And it was these memory gates that gave your long short-term memory model the ability to be far more context aware of the words. So rather than it generating something like, looking at the word server, a server might mean somebody who's serving you some food, right? Or a server might mean, a commodity piece of kit that you've got running in a server farm. And it needed to be aware of the context of those words preceding it to be able to understand, there should be somebody serving something compared to an actual server. So a lot of this stuff kind of worked, and it was those memory gates that really gave you that value. But language models are moving quickly now, right? So really there, we're kind of talking the late 2016, 2017 with LSTMs. Out of interest, like LSTMs still actually have a lot of value. They're actually very good for things like, for anything that requires you to do something very iteratively and hold memory, forecasting and things like that, you can do quite well with an LSTM. But we got to the point where a paper was released. And this paper was called Attention is All You Need. And the Attention is All You Need is one of the very early papers that focused around this concept of a transformer. And it is transformers that are really the grunt of of what we've been looking at with language models today. So one of the problems with LSTMs and anything that requires a recurrent neural network is they were very, very serial. So the challenge of being able to train a huge, huge recurrent neural network was that we couldn't really parallelize it. And it was the parallelization that we really needed in order to build out better and bigger models. And this is where this paper really set the standard or the early ideas for how we go about parallelizing kind of an RNN kind of based way of working to start building out models that were more complex and models that allowed you to do far more interesting things. And so it almost felt like, it kind of got to the point where every week there was a new model being created. And every week there was this kind of like competition to see who could do the best, right? And so here in a picture, you might not be able to see it very well, but you've got time, and then you've got the number of million parameters. So it started off very early with the Elmo paper, which was looking at something like 94 million parameters going into this. So if you think even about a recurrent process, a recurrent neural network with an LSTM, really training that with 94 million incoming parameters, tokens, that's a huge, huge amount of work. So being able to distribute that is really how you can get the success there. Moving on in that timeline, we start seeing OpenAI, right? OpenAI largely dominating at least the news feeds around GPT, with ChatGPT at the moment, right? And that was a very early GPT, and trained on 110 million parameters, and that was just like, right, mind-blowing at the time, that we could do something that had that kind of scale. But then there was more and more and more, right? We went through BERT, we went through GPT-2. There are other ones in here like, there was like Albert, there was Einstein. There are a huge, huge, huge number of models that were being produced. Almost like you look at that timeline, right? And it's like every other month, there was a new, bigger and better model. And all of the big players, right? You look there, like Meta, Microsoft, right? Everyone was trying to build a bigger and better model, and everyone was trying to get that, that rush to basically get to market as soon as they possibly could. So let's have a look at some of these, right? let's have a quick look at how some of these models worked and what they were good at doing. So let me switch over to my internet, and what I'll do is just quickly put my Zoom tools on. 1 second. If anybody ever does presentations, there's a phenomenal tool called Zoom It. I thoroughly recommend you have a look at it. So this is Hugging Face. And one of the things about Hugging Face, as well as hosting a lot of models, Hugging Face is very good at hosting a lot of legacy models as well. So this is Elmo, right? We're looking at that 94 million parameter data set that was created back 2017, kind of 2018. And this one gives you an example of kind of text generation. So in here, what you're able to do is you're able to type something like, what should my next talk at Big Data, not Biff Data, at Big Data London be? And let's compute that, right? So again, this is using 94 million parameters, so 94 million bits of text that have been probably scraped from Twitter, right? This is why Elon is trying to lock down how many tweets you can read, right? Because there's a huge, huge amount of value in that. What should my next talk be like? Okay, not the greatest of prompts. You could do some other interesting things, right, with this, like, my dream is to be able to wear pants. That is true. Thank you, the internet. It's actually been my dream for a very long time. It's held me back in life, but hopefully we'll get there at some point in the future. That's Elmo, right? Simple kind of text generation. We're not really producing the kind of context that we can with other ones. Then maybe we move on to something like BERT, a bit further along in the journey. A couple of, much bigger parameter set, much bigger model. And with BERT, we can do other things, like we can do this with masking text, this example is. So I could say something like, how is this talk going? And type mask in there. And then we can get that to compute. What are the things? How is this talk going today, tonight, right? It's not really the context of what we're thinking about. Again, quite naive in its implementation, quite simple in how it's working. And then you start getting bigger and better models, such as Albert. And I could say, welcome to my big data session. And it's going to populate that with my big data folder session. Maybe not one I'll submit next year. Maybe my big data newsletter session. That might be interesting, might be about marketing, could be interesting, I don't know. Again, these models, able to do some better things than you could with like an LSTM, but really not getting you to the meat of what you wanted to do with this kind of stuff. Yep, wrong one, 1 second. Put the actual one back on here. And then we get on to the new stuff, right? Now we're getting better. We're getting much further down this history line. We're starting to look at things like ChatGPT. And the way a lot of this stuff works, right, is you can think about it as ChatGPT basically being an application that is utilizing a large language model. ChatGPT, isn't a large language model, but it's being powered by a large language model, and then a foundation model, and then generative AI on top, right? It's a clever interface, and it's a clever process that isn't just using large language models, but is also using reinforcement learning to understand and to retrain consistently to give you something that meets and makes reality look that bit better, right? And so when you think about traditional machine learning, the processes that we would go through for each of those examples that we were talking about before with a bag of words model, right, is you would train a model, and that model would be singular in its function. That model could do one thing, sentiment analysis, right? Is this good text? Is it bad text? Is somebody neutral about what we're saying? Doing classification, entity recognition, or any other kind of NLP process. There was a huge, huge amount of value in these, but they were very singular. And so really what we're looking at when we're building out generative models is we want to be building these out in a way that we're able to solve multiple tasks using the same model, right? So you think about what you can do with something like ChatGPT. You can pass it a block of text and say, summarize this, and it will summarize it. You could say, what is the sentiment for this document? And it will give you the sentiment for that piece. You can say things like, how can I change this? What can I do? Can I make this more humorous, make this more funny, right? Do generation and augmentation. And it's able to achieve a lot of natural language processing tasks in a singular model. And that gives us far more flexibility and far more power when it comes to ultimately deploying something. Rather than deploying a number of things in an ensemble, we can look to start deploying just one thing that enables us to do far more. And we can get that deployed quickly into our own applications and get that deploying across our business. And so one of the things that we do with a lot of our customers is really help them build out the applications that their model should sit in. Because building out the actual long short-term memory model, the actual large language model, a lot of this stuff is, again, becoming really commoditized really quickly. You look at what OpenAI are doing in terms of giving you the ability to train your own models very quickly. You can pretty much get a model that is incredibly powerful within days. But then the challenge comes in, how do you actually translate that into something that offers value for your business? And that is really where deploying that and thinking about it in the context of what you do as an organization is going to be really powerful. So we had transformers, right? But where are we going next? Transformers seem to be getting bigger and better. There's a lot, obviously, about the legalities around this stuff, people trying to shut down your ability to scrape data from places like Twitter, etc. There are new bodies being brought up around the kind of ethical nature of what we're doing. There are a lot of people asking for things like to slow down the training. And I would always ask that you look at why people are interested in necessarily slowing down and what their motivations might be, especially when Elon Musk. But transformers maybe aren't the end of the journey, right? There's this new paper that was released on the 9th of August, which is all about this idea of a retentive model. And so retentive models, this paper is all about a successor to large language models. And so here we're talking about a concept that is 30 days old at this point. But what we're seeing is that there are new and interesting and novel ways that are continually being developed. And there is this constant rush and this race to get to the point where people want to lead. And it's kind of, you'll read a lot, right, that we're rushing forwards. And a lot of people will argue that we're kind of rushing forwards to the edge of a cliff. But ultimately, we're not going to be able to stop a lot of that. There is a huge progression in terms of the competitive nature, but I don't believe that we're going to stop right with transformers. We're going to find new and novel ways. There will be ChatGPT 5, 6, 7, right, with mega billion, parameters, far beyond the billions of parameters that they are today. And with that, comes challenges in terms of what this can be used for, but used right in your organizations. Today, what we have can be massively transformational for how your companies work and how your companies operate. My final slide and my call to action for you all is to go have a look at stuff, right? Increase your learning. If you want to increase that learning with us, take a look at our YouTube channel. It's Advancing Analytics on YouTube. We have about 300 videos across data engineering, across machine learning, across large language models. And what we want to do is we always want to empower you to be able to take this knowledge back to your organizations and really transform them, right? Do something little, test it out. Watch the videos for a good understanding of how you can build these things out yourself. If you get stuck, hey, we're always here. But we want you to be able to do this stuff yourself, right? So thank you all very, very much for coming today. We have about a minute left for questions, so we might not be able to do a huge amount. If anyone does have a burning question, let me know. If not, 828 is our stand. I will be there for the rest of the day, and our team will be there as well, happy to answer any of your questions around how you get started, how you implement large language models, and how you go from there. And so my last piece is, what should I generate for my next talk? And I've got that here. I'll copy and paste. And let's see if Andy will accept it next year. I've asked, what should my session be next year? At Big Data London, a concept about generative AI that should add some value. So next year, come and watch me talk about unleashing value unleashing generative AI, driving business transformation with intelligent automation. So I will see you here next year, where that's what we'll be talking about. So thank you all very much for your time, and enjoy the rest of Big Data London.